Alright. So hi everybody, I'm Balazs from Nemeth. Today I'll talk a bit about tools and techniques to debug OVS hardware offload. So a bit of background to get started, to get everybody on the same page. Why do you want to have offloads? Well, essentially, CPU resources are quite scarce, and OVS workloads are not that cheap. So what you have to do is when you're running a server, you kind of divide your cluster or your server cores into two sets. One of the cores will do your actual workload, so run some pods or some applications, and then you also have some CPU resources which are dedicated for the networking part. That's kind of a shame because you actually have quite many cores that you are sacrificing this way. So that's why you try to introduce a special kind of networking interface card, which is capable to do all the networking stuff. That's how you can free up some cores and you can run more applications that way. An important thing here to note is that the offload itself is completely done transparently. So from a user's perspective, as an application writer, you don't need to know exactly how the details work, just get the benefit from it. Of course, there is a very big downside to this. When you want to debug this, it's not so trivial. So what's really happening when you're doing an offload are essentially four components that are important and are at play here. So at the lowest level, you have the actual hardware, which is typically configured in something called the vSwitch mode. It's very fast, and if packets go completely through the hardware, the software doesn't see it. So this is your ideal situation. And in some cases, the hardware doesn't know how to handle it. And in that case, you have a fallback. The first thing it goes to is the TC software part of the kernel, which is also quite fast, but it's already a bit slower. So this is something you already want to avoid if you want maximum performance. And if for whatever reason there is also something wrong in the TC software part, then there's another fallback to the OVS kernel data path, equally fast, but also like another level of fallback. And then finally, which is the worst case, you end up in user space. This is the slowest, but in some cases we kind of see packets going there too. So this is kind of the picture you need to keep in mind when you're debugging the offloads. Different diagram, which I like to show you as well. It's actually the same thing, but more in detail. So what I'd like to point out here is that when you have your application running, you assign a virtual function to that application. That's what you see on the right. And if your NIC is in vSwitch mode, then there is also a virtual function representer associated with that virtual function. And what's actually happening is when your packets are traveling through the stack, your application puts the packet to the virtual function. If all goes well, it goes directly out of the interface and you never see it coming back to software. But if it doesn't, like especially at the beginning, the hardware doesn't know how to handle it, and you will go through the stack and hit many different places, and that's kind of outlined here. Another thing that I'll talk about later on, and if you look carefully in this diagram, at the top you can see OVS with OVS vSwitch D, and it's installing flows either in the OVS kernel or in the TC software part of the kernel. So it's either or, and I'll come back to that later on, just something to keep in mind. So now let's actually go to your mental model when you're debugging this. So typically you have like a server and a client or a source and destination node, and then you have these four components, and traffic is going bidirectionally. So essentially there's four different places where it can go wrong, on the egress and on the ingress on both sides. So the first thing you want to do as a debugger is you want to run some performance tests. So you use iPerf. You run this iPerf server on one side and the iPerf client on the other side, and then you start running traffic. There's some parameters I put here which are very useful when you're debugging this. For example, the -R reverses the traffic because iPerf works in one direction, or if the real payload is going in one direction, and reverse just reverses the direction of the payload. And you can also specify the port and stuff like that. And you want to run for a long time because I guess the default is 10 seconds and you don't debug in 10 seconds, so you put something large. So what you're seeing here is the output of top, and you can see like all your cores are not really working, right? They're idle. And there's of course iPerf running in user space. it takes some cycles, but all in all, you're kind of not doing much because the hardware is doing all the work. Now, if you also look at the output of iPerf, you can see quite nice performance, 20 gigabits per second. So based on this, you would conclude that offload is working quite nicely. And if you take a different setup, you might see something like this. So a different test, but in this case, you do see more processes using the cores. So you can see OVS vSwitch is using a lot of CPU, and then you have also a bunch of kernel stuff taking your CPU. So this is already giving you an indication that something's wrong, right? And especially if you look at the output of iPerf, only just 100 megabit per second, so clearly, or sorry, 100 megabytes per second or 800 megabit per second. So clearly something is wrong. At this point, you know that you need to dig deeper. All right. So the first thing you might use is eth-tool. It's a pretty well-known tool. The downside is kind of that your mileage may vary with what you can do with this tool because it's very hardware specific. So what you have to do is you have to run eth-tool either with a virtual function or virtual function representer that I talked about earlier, and you'll get some statistics if it's supported for that particular NIC. And in this particular example, I'm running a Bluefield, and you'll look at the rates in which V-port statistics are increasing compared to normal statistics. And what you have to keep in mind is that the bigger the difference between the rates that these two statistics increase, the more work hardware is doing that software is not. So that's what you want. But if the rates are increasing similarly, that's an indication that something's wrong because you want to do more in hardware than in software, of course. So it's quite high level, but it already gives you some ideas. The next one, more interesting tool to use is TCP dump, of course. So what you will have to do in this case is you pass the virtual function representer to TCP dump. And if you do this before traffic starts, you will always see some of the packets shown in TCP dump. And the reason for this is because initially your hardware doesn't know how to do the offload, so it will talk to software, and that's why you see the first few packets going through TCP dump as shown in the terminal. But after some time, you expect to not see this anymore. And if you keep seeing packets there, then hardware is not offloading it. So then you need to start looking further. Now there's a caveat that you have to keep in mind. If you're running this on the egress side of your traffic, there's a TC hook, which is before the TCP dump hook. And for that reason, this is not so reliable in this particular instance. Unless, again, there's an exception to that. If you're running your flow that hits the last interface that's in that particular instance, then this can be useful as well. All right. So the next thing, now that we know that something's wrong, you want to dump your flows, right? So the typical command that you run is shown at the top, and then you get a bunch of flows shown on your screen. And it can be quite overwhelming, especially if you have a real setup like OpenShift. And there's like a lot of traffic in your system. It will show many, many flows. And it's hard to see the forest through the trees, or the tree to the forest. What you actually can use is a tool called OFParse, which has been presented last year by Adrian. And it's very useful because if you can pass the heat map flag, it will kind of highlight which flows see a lot of packets. And those are the flows that you want to look at, right? And another thing that you then do is you get rid of the flows you don't care about. So you have a list of flows that are really being hit by the traffic that you're running in the background. And then there's one more step you need to do, is you need to order these flows because the output is not really ordered. So based on the recirculation ID, that's like the last part of each of the flows, you can have like a sequential ordering, and this will be much easier to understand and debug. So if you look in this example here, what you can see is that this particular flow is using data path OVS. This tells me that this flow is not in TC, so that's definitely something wrong. So it's already far away from the hardware. And this other one is it is in TC, but it's not in hardware, because if it would be in hardware, you would see something like offloaded yes. Right? So this is what you want. Now this actually has also some caveats. It can still miss in CT. I'll come back to that later on. But this is what you typically want to see for your flows. Right, so once you have all these flows ordered, and something is wrong, at some point a flow will be handled in software. And the rule of thumb that you have to keep in mind is all that the subsequent flows after that will also be handled in software. Those flows could be in hardware, but they will still be handled in software because once you go for the software part, then you cannot go back to the hardware. Okay, so if you want to look into contract, then you can copy this file, and then you can grab for your vSwitch to see your actual tests running. And you're looking for something, a flag there called hardware offload. This one means that it's really handled in CT. But again, there's an exception. If there's hardware offload, it doesn't mean it's properly offloaded in DC. Like it could be like only one direction is offloaded, and it will still show hardware offload. So it's not like clear cut. But what you can say is that if you don't have hardware offload there, it's definitely not offloaded, right? So you turn it around. Okay. Another thing you can do is you can force upcalls. It could be useful in some particular instances to use this technique. And what you actually have is, I've talked about this earlier, is you either have the flow in OVS kernel or in the TC software part of the kernel. And if you're assuming that it's not hitting the TC hardware, you can tell it to skip the software. So that means that you will be skipping this orange box or the yellow box, and you'll kind of be forcing an upcall in that way. So this is also a useful technique to know. And then there's again a caveat. This one is not really, this technique is not really compatible with CT hardware offload because tunnels are also problematic because if you put skip software, then that feature will not really work at all in hardware, so you can't really debug it, right? So you actually need software part for that to work properly. Okay, so the next thing is to really look at OVS logs. So in the past, what we had is we had this very generic operation not supported error coming, and we just printed operation not supported because that was the only information we had. But we did extend that with something called extended X. And instead of a single integer, you actually get a string, which is much more useful to debug. So this is something we added. So definitely don't forget to look at the logs as well and give you an indication of why something is not really working. So if you go deeper to the TC parts, there's this TC filter show command. It will give you the current state of TC. And what you will be looking for is two statistics, send hardware and send software. And the first thing that you want to see is that you have separately send software and send hardware. Because if you only see something like send hardware, it implicitly means that everything is handled in software. So send hardware is implicitly 0. And then definitely something is wrong with that particular flow. And then you need to debug why that's wrong. Another thing that you can use is TC monitor. This one is more dynamic. So you can run this while your system is adding and removing flows, and then you can understand when stuff happens. You'll just get like output as stuff happens, like added and deleted. So this is also very useful. Again, it just tells you that stuff is happening, but not why, of course, right? So that's still a difficult part that you have to figure out. So this is the conclusion. I have a demo as well after this one. So let's go a quick summary of the presentation. So offload failures usually do show up as degraded performance because that's kind of what offload is trying to do to get good performance. And your main symptom will be that your CPU is doing too much work, right? And your throughput might be lower as well. So it's also those main two things you will see. In general, and this is with the big asterisk, things don't break because it should work transparently. But if for whatever reason some part has a bug, of course, the connectivity might break if you enable offload, which is a bit weird, but bugs happen. So as we've seen, there are many components at play. So it only works correctly if all of those things work properly together. And then if there's an issue in one of them, then you might see some issues. So this presentation gives you some tools and techniques to do the debugging. So we tried to first see if we have an issue, and if we do, then we figure out which flow is giving you an issue and in which layer the issue actually is. And then it's still up to you to go to that part of the code to do the actual debugging. I didn't talk about firmware, but trust me, this one is very important. Make sure you're running on the last one. And there might also be some very firmware-specific tools that can also help to understand why stuff is not really working. I try to cover as many things here as possible, and you might have your own use case, and you might see that you don't understand why it's not offloading. Please let us know, and then we'll try to add some tooling or to figure out a way to debug that as well. All right, so I have a demo left. So what we'll try to do is we'll go into an OCP cluster that runs with the Bluefield, and there's offload not working, and I can try to show you that. So let's go there. Okay. All right. So you can see here I have a cluster, like a Kubernetes or OpenShift cluster. You have a few nodes here, and I know where it's breaking, so I'm going to go directly there and show you how it actually looks like. So there's in this cluster a bunch of pods running. So these are all the pods, and there's also services, and one of the services is backed by a pod. So this particular service is backed by a pod. So if you get the information about the service, you can see there's a pod behind that one. And if I go to that pod, I know that this pod is running on this particular node. And I know that the use case that doesn't work is if you have another pod running on the same node, so a client pod, that talks to that server pod, the offload will not work. So let's go into the client pod. And on the server side, there's already iPerf running. So you can run your client. So it's connecting. And what you can see is that the bridge rate is quite okay. So you might say, okay, this seems to be working. But what I already said is that iPerf works like there's the traffic payload is going in one direction. So if you can test in a different direction as well, you should do that too. And you can see in this case, if the payload goes in a different direction, performance is quite low. It's like 800 megabit per second. And again, you probably want to run your test much longer than 10 seconds. So there you go. And at the same time, what we'll do is now look at how the server is behaving, right? So I take a new terminal and go to the node that I'm debugging, get the IP address. So if you look at top here, right, you can see there's OVS is running here, right? iPerf is running, and there's a bunch of kernel stuff going as well. So you would not expect to see this. So something is definitely wrong. And so what we'll do is we'll try to do TCP dump on the virtual function representer of the server. So we need to figure out which virtual function representer is in that server pod. So let's get all the containers, and this is the server pod. I'm trying to get the ID here. And then there's some technical way to figure out the name of the virtual function representer. So this sandbox ID is the part of the sandbox ID is actually the port name. And if we want to do TCP dump in OpenShift, that's a bit tricky. You need to do that in a separate container. So I have a debug container running here. I can show you that as well. So this is my debug container. Go inside the debug container. And then I'll do TCP dump on that interface, right? So my traffic is still running, and you can see like a bunch of packets. And if you look closely, this is something you would not expect, right? So the next thing is I'll go outside of my container and then run the dump flows. And as I said, this one is a lot of output. And I'm going to cheat a bit because I know why it's failing. So I'm going to find the flow that's failing. I just need a second for that. So this is the flow that's giving some issues, right? So what you can see is there's data path OVS. A bunch of packets are hitting this one. So it's definitely used a lot. And it has a recirculation ID shown here. So I'll go to the one before that, that's also being hit quite a lot. So that's this flow. And you can see this one is offloaded, right? So this is TC offloaded here. So this one looks good. But what happens afterwards, it goes to this flow, and this one is DP OVS. And the reason for that, I can already tell you that the clone action is not supported by the hardware. That's the reason why it's not offloading. But again, we need to still kind of figure out why exactly that's happening, but at least you know that this is the flow that's giving you issues. All right, so that concludes my presentation. I think I can take some questions now.
All right, let's thank our speaker. I do know that we have some questions that came in on chat, but before we get to those, while we wait for that 30 seconds, does anyone have any questions for Balazs right now? Okay, I have a question actually. This talk showed a lot about sort of identifying where things are failing, but maybe the how or why things are failing, it doesn't seem so obvious. So is there going to be any effort to improve that?
So it really depends on the components themselves. As far as I know, that part is up to the developers of that part, of the parts that are failing. So as far as I know, there's no real easy way, except for extended X, that can help to understand why. But otherwise, it's still an effort that you have to do yourself in the end.
Hey, Balazs, we do have a question from Gavin in the chat. He asks, is it possible to determine the reason why a TC rule is not offloaded? I'm trying to debug offload on an OVN gateway, no SRIOV, using physical ports only. All I ever see is not in HW flag, but can't see a reason why this is. For a little context, I'm trying to troubleshoot hardware offload on the Mellanox Connect X6 on an OVN external gateway, no SRIOV, just physical function.
So it's actually kind of a similar answer as to Aaron's question. To actually really understand that, you have to understand the parts where it is failing. So actually, you identified already where it's failing, but you need to now understand the code. And it might be really due to the hardware. Like it might not be implemented in the hardware at the particular point in time. So you might need to upgrade. Make sure your firmware is up to date for sure. But yeah, could be very much the reason might be that the hardware just doesn't support it.
Okay, thank you.
Okay. Any other questions?
Can you just talk or do we need the mic? I'm somewhat aware that different network cards might support different actions. Is there any sort of centralized list or data source that would say what network cards might support what offloading of what?
That's a good point. So shall I repeat the question? So the question is if there's a centralized resource where we can see what type of flows are offloadable by which type of parts and which versions, etc. At this point in time, we don't have that yet, but I think this is being worked on. It would be something that we will be releasing soon and would allow you to really just know that, okay, this is something we cannot do on that particular NIC or something like that, yeah.
All right. Any other questions for Balazs? Okay. Well, thank you for presenting.